Alright, hello again. This is Jeff Scott for Data Dimensions with the last presentation that I'll be making for you. What I did was I went out to, as far as I know, the newest version of the Microsoft Security Development Lifecycle, or SDL, version 5.2, which is out on the Microsoft Developer Network site. And I grabbed this 55-page document, went through it, and tried to pull out what I considered to be the most relevant information that was in there. Now, much of this stuff is going to be review, but what I'm trying to do is tie everything together and for the last time and just go over what we've actually gone over in the past 16 weeks. So like I said, this is whatever, 16 pages, or I'm sorry, 55 pages or whatever. But I want to go through the equivalent ones that are the stuff that I've put into the slideshow. So that's what I'm going to do for you right now. It's going to take my time. I'm not in any hurry. There are somewhere around 87 slides, and these are all things I've created, but I've taken the stuff virtually directly from that document that I showed you. I entitled it Microsoft Security Development Lifecycle Postmortem, as we're looking at this at the very end here. So I'll give you a little bit of introduction, and then I'm going to break it down into the actual phases of the Microsoft SDL. So we start with pre-SDL requirements, in other words, the security training. Then we go into requirements, then we go into design, then we're going to go into implementation, followed by verification, followed by release, followed by requirements, the requirement response. All right. Again, all of the information that you see here, I got from that URL, the one that's shown right there. Now, unfortunately, I have to reposition my equipment a little bit, so I'm going to have to pause this for just a second, and then we'll come right back. Alright, so as I go through this, you might hear a little bit of rustling of papers and the like, because I'm just trying to make sure, again, that this presentation does stay in tune with the actual document itself. So, remember, this is the Microsoft Security Development Lifecycle, or SDL. So again, we're going to break it down. We're going to talk about what goes into the training, what goes into requirements, what goes into design, what goes into implementation, what goes into verification, what goes into release, and what goes into response. All 7 of the steps in the cycle, basically. And we're not going to go through any of these in any depth and breadth of coverage, because let's face it, we've already done that. All right, we've already talked about, we've had entire presentations on some of these things like threat modeling and fuzz testing and some, attack surface analysis, etc. So we've talked about a lot of these things. So, Microsoft mentions that secure software development is mandatory for software that is developed for any of the following uses. Anything that's used in a business environment, anything that's used to process personally identifiable information, or PII, and any kind of an application that communicates over the internet or any other network. Now remember, this entire thing that they're talking about in here is in response to the Microsoft Trustworthy Computing Directive of 2002. I'm not going to go into that a bit. You can see it's 13 years old. But basically it was a letter that came down, or an email that came down from Bill Gates to the Microsoft employees saying, we're not doing a good enough job of being secure, and we're going to improve. It's interesting, last night I was watching, I'd seen it on TV already, but I was watching, for a while, I watched part of the movie Moneyball, which you may or may not have heard of, but Moneyball is a concept that's used by the guy who's still the general manager of the Oakland Athletics, Billy Beane. And the idea is he uses the computer and he figures out the best matchup, the best players to play, etc. And he did all this stuff. And when he first started doing it, the manager wouldn't listen to him. And he played the players he wanted to play anyway, etc. But eventually he gave in because he had to. And all of a sudden the Oakland A's won, it was like 19 or 20 games in a row. So what does this have to do with anything? Well, what I'm saying is Gates was kind of the Billy Bean. He came through here and he said, we're going to do it this way from now on. And as the guy, runs the place, people fell into place. So when this started, one of the first offshoots of this, and we looked at this in a much, much earlier lecture, was something that's referred to as SD3 plus C, which stands for Secure by Design, Secure by Default, Secure by Deployment, and Communications. So as we look at these, each one in order then, all right, Secure by Design, as you can see, the developers have to consider security issues from the beginning. In other words, they're part of the basic architectural design of software development. Threat modeling and mitigation. Threat models are created. They're present in all design and functional specifications. We had an entire talk or two on threat modeling, and we went over the Microsoft threat modeling tool. Elimination of vulnerabilities. After you review the code, ideally there are no known vulnerabilities that exist. And improvements in security. The idea with as old code is deprecated and replaced with new code, the new code will be written to adhere to the ideas of the SDL and will be more secure for that reason. Secure by default. Remember that principle of least privilege that says that all software components are to run with the fewest possible permissions. Defense in depth. In other words, don't rely on one single mitigation solution. Because if that fails, where are you? Combine a lot of different things. Have conservative default settings. In this way, the development team will be aware of the attack surface and will be able to minimize said attack surface. Avoidance of risky default changes. Applications don't make any default changes to the operating system or security settings that reduce security for the host computer. And then finally, least commonly used services off by default. We've mentioned this before, that if fewer than 80% of a program's user use a feature, the feature should not be activated by default, but it should be easy to activate, and there should be plenty of documentation, both written, online, as much as possible for how to actually activate the feature if need be. And then there's secure and deployment. You should have deployment guides which outline how to deploy each feature of a program in a secure manner. Analysis and management tools to enable administrators to determine and configure what would be considered the optimal security level for any software release. And then patch deployment tools provided to aid in patch deployment and coming out on a regular basis and doing their job. Finally, you've got communications, security response, where the development teams respond promptly to reports of security vulnerabilities, and they communicate information to users and whomever regarding upgrades. Finally, community engagement, where development teams proactively engage with users to answer questions about vulnerabilities. They're working together. Now, an analogous thing to SD3 plus C is one that's PD3 plus C, which is privacy by design, privacy by default, privacy by deployment, and communications. So let's just take a minute and go over those. Privacy by design, the first thing says privacy notice and consent. You want to provide appropriate notice about data that's collected, stored, or shared so that users can make decisions about their own personal information. Enable user policy and control. Allow parents, for example, to manage privacy settings for their children. Minimize data collection and sensitivity, where you collect the minimum amount of data that's required for a particular purpose, and you use the least sensitive form of that particular type of data. Finally, protect the storage and transfer of data, where you encrypt personally identifiable information, that PII. You limit the access to stored data, and you ensure that data usage complies with what's been communicated to the customer. Privacy by default, again, you ship with conservative default settings. You're always trying to protect personal data. Privacy by deployment, again, with publishing deployment guides so that customers can establish their own internal privacy policies and maintain their privacy and their employees' privacy. And finally, communication. Publish author-appropriate privacy disclosures. Promote transparency. That's such a big word today when people talk about being transparent. You know, making everything available regarding whatever it is you're talking about, in this case, privacy. The establishment of a privacy response team. You're creating a staff that's going to be responsible for responding if there's a privacy incident that occurs. So, the Microsoft Security Development Lifecycle, as said there, it consists of a list of proven practices that Microsoft has used to successfully develop their recent products. This SDL is looked at, updated as necessary. At a minimum, it's looked at twice a year. For that reason, you know, what we just talked about, it must continue to evolve and use new knowledge and tools as they become available, ideally, as mentioned there, to build even more trusted products. Alright, so let's jump into the first part of this, which is the pre-SDL requirement of security training. We've talked about this before, that all members of Microsoft software development teams have to, at a minimum, attend at least one security training class a year. That doesn't mean they sit down for an hour. Typically that's at least a day, and sometimes these classes can last up to a week. So we're talking about possibly up to 40 hours per year that these individuals are taking away from their work time to become security trained, which hopefully will help them in the workplace. So some of the stuff that's discussed in here. The basic concepts include secure design things like attack surface reduction, defense in depth, principle of least privilege, secure defaults, different parts of threat modeling, you know, an overview, the design, how to code to a threat model, how to test to a threat model, units on secure coding, buffer overruns, integer arithmetic errors, cross-site scripting, weak cryptography, SQL injection, managed code issues. These again are all things that we have talked about. Security testing itself. Alright, security testing versus functional testing, risk assessment, different test methodologies, and automation. Privacy, we've already hit on some of this. Different types of privacy data, privacy designs and best practices, risk analysis, and privacy development and testing best practices. Then we get into the advanced concepts that are discussed. Security design and architecture, user interface design, security concerns in detail, security response processes, and implementing custom threat mitigation strategies. This leads into phase one, which is the requirements phase. Alright, in the requirements phase, it includes the project inception, where you consider security and privacy at a foundational level, and it also includes cost analysis. And cost analysis is when you determine whether or not basically what you're doing is worth the time and effort and money that you're putting into it. So what are you attempting to do here? Well, one of the first things that you do is you develop a questionnaire to see whether or not the project that you're about to embark upon even needs to be subject to SDL policies. From there, you're going to determine, yes, it is. So it must be assigned a security advisor who's going to be your focal point, your contact point. They're going to be in charge of the FSR, or Final Security Review. Again, if it's subject to SDL policies, you'll have to do a security risk assessment, or SRA. It'll be mandatory that you do that. On the other hand, if it turns out that it's a very small internal-only project, maybe it's not subject to SDL policies. And if that's the case, okay, it will be classified as being exempt. So what does this all involve? Well, things like privacy requirements. As mentioned here, you're going to identify the team's privacy advisor. You're going to identify somebody else who's probably a programmer who is the privacy lead or the privacy champion, who's going to be responsible for implementing the privacy inside of the project. You're going to define and document some kind of a project privacy bug bar, which will differ depending on the company that's working on it. From here, you'll start to go over your stuff and you'll figure out exactly, all right, as you're going over it, the different levels of privacy that you have. And they can be P1, P2, or P3. P1 is the most severe because most of it is personally identifiable information, or the PII. P2 is moderate privacy, and typically what that is, as mentioned there, is it's a one-time anonymous data transfer that you're doing over a network. P3 is no privacy risk and no data transfer taking place. Now, I talked about cost analysis a little bit. Again, you have to understand the costs and requirements involved. Every single time that you add privacy, that you add security, it's going to cost money. It's going to cost people power, and that's not just at the programming level. It'll be at the design level, it'll be at the support level, it'll be at the documentation level, etc. Right? So these are all things that you're going to have to be, concerned with. Some of the security recommendations that come out of here: you'll have to do team training. You'll have to go through threat modeling. And as we talked about much earlier in this set of presentations, is that the earlier that you do threat modeling in the process, the cheaper it'll be to find and fix errors from the get-go. But you don't just do threat modeling at the beginning of the process. You do it throughout the process, at a minimum at the beginning, somewhere around the middle of the process, and before the end, before the final release. You have a security push, and we're going to talk about that in much more depth and breadth of coverage in just a couple minutes. Before the software goes out the door, and typically anywhere from 6 to 9 weeks before it goes out the door, you have a final security review where the security team and any other person who's involved in security looks at the product to make sure that everything that you're claiming the product is, it is. You utilize Stride. We had a big lesson on this. Remember that when you utilize Stride, you're either going to say that something is not a security bug, or it is, and when you do, you're going to see what combination of spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, etc. is being used in here. Ideally, you want to reduce your attack surface. All right. From here, we jump into phase 2, which is the design phase, so phase 2 of our process. In the design phase, as mentioned there, you're building a plan for how you're going to take your project through the rest of the SDL process. You're establishing best practices, you're performing risk analysis, all right? As it says, you're trying to identify threats and vulnerabilities in your software, and as previously mentioned, the faster, the sooner, the more upfront in the process that you can do this, the less it'll cost to fix any potential problems. As mentioned here, design specs should describe how to implement these features and how to implement all functionality in a secure manner. Complete a security design review or an SDR with a security advisor for any project. Now, it says some low-risk components might not require a detailed security design review. Notice the word detailed. It does not say they don't require a security design review, but it might be a lot more informally done. What typically comes out of this? Well, as you can see here, some of the recommendations. How you can better measure your attack surface. All right. How to create or conduct project structure or layering. You know, if you've got highly structured software and if the dependencies in there have been well defined, it's less likely to be vulnerable to attack than software with less structures. You want to minimize, again, the attack surface, as we've already talked about. You want to enable least privilege. You know, this is something, again, that we've talked about again and again and again. Also, again, as we've talked about, considering a defense in-depth approach. All right, from there we jump from design into phase 3, which is implementation. Here is, you know, this is where the end user really starts coming into play. We're creating the documentation and the tools that the customer will use to figure out what parts of the software they want to deploy by default. All right, working along with the developer and what they don't. And you're coming up with best practices. These best practices, as mentioned, will be used to help detect and remove, you know, security and privacy issues, and again, as early in the process as possible. So how are we doing this? Well, the development management, program management, user experience teams are going to meet to identify and discuss security needs. They want to define realistic use and deployment scenarios and consider what documentation needs exist. So the user experience team are going to plan to create user-facing security documentation and user-friendly. The privacy recommendations that come out of this, as mentioned, if the program contains privacy controls, you want associated deployment guidelines. You want to create content that will allow users, if certain different things have to be, you know, certain pieces of information have to be gathered, that they're done in the most secure way possible. We want to establish, communicate, and follow effective practices. All that stuff should make sense. You want to utilize code analysis tools. You know, don't use banned APIs. Use integer-safe arithmetic. Use secure cookies over HTTPS. All right? That leads us into stage 4, and stage 4, or phase 4, is the verification phase. And as mentioned right here, during this phase, you're ensuring as best you possibly can that your code meets security and privacy tenets that you established in the previous phases. All right? Again, nothing is foolproof, and you're trying to, throughout this process, to identify potential security vulnerabilities and fix them. But again, you're not going to catch everything, because as long as software is made by humans, there will continue to be error, but you're trying to mitigate the amount of error and the amount of problems that are put in there from the get-go. Again, this is done through security and privacy testing, and then a security push. All right, the security push, which we'll talk about in just a minute in more depth and breadth of coverage, a lot of times it's a week-long activity where the team focuses on everything security. Threat model updates, code review, testing, documentation, review, and edit. And the idea there is they're looking to find possible security problems. During here, a public release privacy review is also completed. And the reason that that's important is that since it's public, typically you're bringing in the end user to do this along with the people creating the code. So security testing addresses two areas of concern: confidentiality, integrity, and availability of software. All right. This is going to include all features and all functionality designed to mitigate threats. Those threats that have been described in the threat model. Freedom from issues that result in software vulnerabilities. You know, I gave an example here of a buffer overflow. All right, that could be exploited in ways that have security implications. All right, that security push I mentioned before, and I put a little bit in here. I have no idea whether or not you guys do a security push or are going to in the future do a security push, but you'll notice, as it says, it's a team-wide focus. All right, it doesn't mean that you don't build in security from the get-go, but what it means is you're taking some time to just try to address security issues. So as mentioned here, it's an organized effort to uncover changes that might have occurred during the development process. Typically, this push occurs after the product has entered the verification phase. All right, around the time you begin beta testing. And a lot of times, at least at Microsoft, what they do is they take a whole week out. I'm not saying a whole week off, because it sure wouldn't be off. But they take a whole week out, all right, and just start to look for security problems. It's important to realize, I think I put it in here someplace. There, I even put it in bold. The goal here is to find vulnerabilities, not fix them. You're trying to address security in here, and remember, you've got anywhere 6 to 9 weeks or maybe even more here before the product is released. So if you find vulnerabilities, you want to go through all the code and identify as many latent vulnerabilities as possible so you can come through and, ideally at least, try to fix them. So you should allocate time and resources in the project schedule for doing this. The security coordinator should determine the resources required, organize a team, create the supporting materials and resources. This same security representative should determine how to communicate the information to the rest of the team. It's good if the team that's going to be doing the push comes in ahead of time and has an idea of exactly what it is they're supposed to be doing. So there must be well-defined criteria to determine when the push, what's going to be pushed and when the push is complete. Now this will take less time if you keep your threat models up to date, if you're accurately tracking and documenting your attack surfaces and any changes that are made to them based on anything that has been done, if you complete your security code reviews for all priority code, if you identify and document development and testing contacts, if you brought all legacy code up to current security standards, and you validated the security documentation plan. If you've gone through all that stuff, okay, what you're going to find is it's going to work much better, much crisper, and the security reviews are going to be much more, or the security push will be much more successful. What you're hoping to do out of this is, we've already mentioned, is to identify, you want to identify, again, potential security vulnerabilities. You want to review and update your threat models, and you want to review any bugs that you found, again, some kind of a security bug bar. The recommendations is mentioned in here. You're conducting these security code reviews for your at-risk components. You're prioritizing your code. You're reevaluating your attack surface, which leads into our release phase, which is phase 5, the final release. As mentioned here, this is when you're readying your software for public consumption. And you're readying yourself and your team with what's going to happen when the software leaves you and goes into the hands of your user. So it all involves planning. All right, it's the planning, it's the mapping out a plan of action. All right, and as it says, it's going to carry over into the post-release that we'll see in just a minute. So you've gone through, you've had your security review, you've gone through and you've done your security push. So now you want to do your FSR, or your final security review and privacy review. All right, you're going to review and update any kind of forms that you have, your disclosure forms or whatever. As mentioned previously, planning is key here, because any software that's released at least has the potential to have problems, no matter how well it's been checked. As mentioned here, even programs with known vulnerabilities can be subject to new threats as they emerge. Privacy advocates might raise privacy concerns after a release. So you must be prepared as early as possible to discuss, and respond to any potential problems. Again, notice if you build the planning into the system, ideally when, not if, but when these issues come up, they can be handled as efficiently and as quickly as possible. The associated security requirements, as it says, the project team must provide a contact for people who respond with any kind of security incident. And it's going to be somebody who's got some juice. In other words, it's just not going to be some programmer that they lay this off on, and I don't mean to demean some programmer, but it's going to be somebody that is a maker and shaker at the place. The project team must create a documented sustaining model so that not if, but when problems happen, patches can be created and dispersed immediately. There must be a consistent and comprehensive policy for security response. So how do you do all this? Well, the security requirements that are discussed in here is you disable tracing and debugging, prior to employment. If you've got P1 and P2 projects, you identify who your leader is going to be to respond to the privacy incidents that may occur. You identify additional people on the project team to work on privacy incident response issues. You have your final security review. As it says, you determine whether or not the software is secure enough to ship. That's what the FSR does. And based on that, the team is going to go through it one last time and identify any additional security requirements. Now, when you do this, all right, you should do it, as it says, at a minimum of 4 to 6 weeks before you release it. Now, notice it cannot begin until you have completed all the milestones. So your in-depth bug reviews, your threat models, your running of all SDL mandated tools. So when you go through the process, as it says, you submit exception requests to the security team. But the big thing is, based off of this, one of three things is going to happen. Either you're going to say it passed FSR. So you've identified any issues that you might have, and they've been corrected before the release. All right, and the security advisor should certify that the project has successfully met all of the SDL requirements. So it's passed. Basically, you're done. There's a pass, but with exceptions. All right, and as it says there, if all issues identified are corrected, then it says you're able to go on. And finally, FSR escalation, which means that for whatever reason it doesn't pass. All right, and I'm going to just give you a quick analogy here, which may be a good one and may not be. When I went and created my master's thesis, I had to go in and give my thesis, and the idea was I was going to give it in front of 2 different professors. Based on the way that the thesis went, I would have gotten one of 3 grades. I would have gotten a pass and go on, a pass, or a fail. So what's the difference between a pass and go on and a pass? Well, a pass and go on means that not only did I pass where I would get my master's degree, but I also could go on, if and when I wanted to, into the doctoral program. If I got a pass, what it meant was I passed and I got my master's degree, but for whatever reason, the way it was in a current format, that until it was fixed and I represented, I couldn't go on into the doctoral program. Okay? And then there was fail. Well, and I won't lie, I'll tell you the truth and I'll tell you exactly what happened. All right? On the day that I gave my proposal, I got there an hour early, even though the people I was presenting to weren't ready, but I got there an hour early. This was not in the days of PowerPoint. So literally I had about a 450-page typed, well, it was not typed, but it was on a computer, but a 450-page printed document. I had 3 copies. One for myself, one for Professor Carlson, and one, I can't remember the guy's name, but for another professor that was there. Professor Carlson, I remember him, Robert Carlson, because he was my advisor. So It was supposed to start at 10 o'clock. I got there at 9 o'clock. That was the third time I'd driven down to Chicago for my classes at the Illinois Institute of Technology. So I'm waiting. It's 9, it's 9:30, it's quarter to 10, it's 10 to 10, it's 5 to 10, it's 10 o'clock. Dr. Carlson comes out and says, Jeff, I'm not sure where the other professor is. I've tried calling him, I've left messages, etc. We wait. It's 10:10, it's 10:15, it's 10:20, it's 10:30, it's quarter to 11. I'm getting scared now. Finally, he does get a hold of the instructor. As it turned out, it was the first day that, down in the Chicago area, it was over 70 degrees. And he'd forgotten all about this and went out and was at the beach and was out with some friends and wasn't coming. Well, I asked Dr. Carlson, what does this mean? And he said, well, I've got good news and I've got bad news. And I said, fine, go ahead and explain all of it to me. He said, the good news is you pass. The bad news is I can't give you a pass and go on because 2 people have to sign off on this. So in other words, I got my degree, all right, but since there weren't 2 people to okay everything I was working on, I couldn't get the pass and go on. And it just went in as I passed. So, Dr. Carlson is holding this big volume of paper that I have, and he said, let's do this. Rather than you going through all this stuff, why don't you critique the program? You critique every class you've had, every instructor you've had, and why don't you start with me? Now that was fine with me, and we ended up spending well over an hour going over all this stuff, in fact closer to 2 hours. The only problem with that was that I had spent literally days preparing to go through all this stuff. And what my thesis was I had taken his notes and kind of put them into book form. So I was preaching to the choir, and even more than that, I was preaching to the minister, or to the reverend, or to the priest, or to the rabbi, or whatever. So he didn't want to hear that stuff because he already knew it. All right. So finally, when you get all done with this stuff, the very last thing that we have in here for the post-STL requirement is response. So after the software program has been released, the product development team must be available to respond to any vulnerabilities that arise, or for that matter, any privacy issues. All right. In addition, they have to be able to develop a response plan that includes preparation for things as they occur. So that's it. I appreciate the people who've taken time from their busy schedule to come and listen to these. I appreciate the attention that people have paid and the opportunity for me to come here. So again, this is what we've been talking about for the last 16 weeks. Hopefully you have a better idea of the Microsoft SDL, what it is, and how to use it. Thank you very much.